Scientists have spent over 40 years searching for dark matter, convinced it holds the universe together. And you won't believe what they've discovered instead. You see, for decades, dark matter stayed at the center of modern physics because scientists were locked in a puzzling cosmic mystery. Galaxies were spinning so fast that based on visible matter alone, they should have torn themselves apart. To explain this, researchers proposed an invisible substance, dark matter, providing the extra gravity needed to hold everything together. This idea quickly became the leading explanation. The more astronomers observed the universe, the more they leaned on dark matter to fill in the gaps. From galaxy clusters to the structure of the cosmos itself, it seemed like the perfect solution. However, scientists began noticing a major issue that couldn't be ignored. Now, here is the truth that the public explanation has almost entirely erased. We have never detected dark matter. We have detected a problem, and dark matter is our preferred solution to that problem. Those are not the same thing. And the scientific community has been conflating them for so long that even most scientists have stopped noticing the difference. Let's go back to where this started. In the 1970s, an astronomer named Vera Rubin was measuring how galaxies rotate. The physics was straightforward. A galaxy is a disk of stars orbiting a common center, the same way planets orbit the sun. And just like planets, the stars on the outer edges should orbit more slowly than the stars near the center. The further out you go, the weaker the gravitational pull, the slower the orbit. This is called Keplerian rotation. It's the same math that describes every orbiting body we've ever studied. Rubin found something different. The outer stars weren't slowing down. They were orbiting at roughly the same speed as the inner stars, all the way to the edge of the galaxy and beyond. Flat rotation curves where the math said they should fall off. Something was wrong. There were two possible explanations. The first, there is invisible mass distributed throughout and around the galaxy. A vast halo of undetected matter providing extra gravitational pull to the outer stars. Add enough of this dark matter in the right distribution, and the rotation curves flatten exactly as observed. The second, our theory of gravity is incomplete. At the scales of galactic rotation, gravity may not behave exactly as Newton and Einstein described. A small modification to the laws of gravity at low accelerations, tiny, undetectable at solar system scales, could produce the same flat rotation curves without any new matter at all. The first explanation won, not because it was proven, because it was more conservative. Physicists were more comfortable adding invisible matter than modifying gravity. The decision was as much philosophical as it was scientific. We chose dark matter, and we built 40 years of cosmology on top of that choice. The second explanation, modified Newtonian dynamics, or MOND, proposed by physicist Mordechai Milgram in 1983, was largely dismissed, ridiculed in some quarters, pushed to the fringe. Here is what that fringe theory correctly predicted that dark matter models did not. MOND predicted a precise mathematical relationship between the visible mass of a galaxy and its rotation velocity, now called the radial acceleration relation. It said that if you know exactly how much ordinary matter a galaxy contains, you can predict its rotation curve with a single formula. Dark matter models couldn't do this. In dark matter cosmology, the dark matter halo of each galaxy is essentially independent. Different mass, different distribution, shaped by the chaotic history of that galaxy's formation. There's no reason the visible matter should tightly predict the rotation curve, and yet it does. Across hundreds of galaxies, across dwarf galaxies and giant ellipticals and everything in between, the relationship holds. The visible mass predicts the dynamics with an accuracy that dark matter models struggle to explain without additional assumptions. This was confirmed in a landmark 2016 study in Nature Astronomy. The correlation was so tight, so universal, that several physicists stated openly it was difficult to understand in a dark matter framework. The data looked like it was telling us something fundamental about gravity itself, not about an invisible particle. Now layer on what the James Webb Space Telescope has been finding. JWST has been observing the early universe in unprecedented detail, and the galaxies it finds, those same impossibly early, impossibly massive galaxies, are distributed in ways that challenge dark matter simulations. The standard lambda CDM model, built around cold dark matter, makes specific predictions about how structure should form, how galaxies should cluster, how large the largest structures should be at various cosmic epochs. Webb keeps finding structures that are too big, too organized, too early. Dark matter theorists have responses. They always do. The model is flexible enough, with enough adjustable parameters, to accommodate most anomalies with modifications. But each accommodation moves the goalposts. Each patch reduces the predictive power of the model. A theory that can explain everything by adding new parameters is a theory that risks explaining nothing. Meanwhile, the detectors have gone silent. The Large Hadron Collider was expected to produce dark matter particles, specifically the leading candidate, the WIMP, the weakly interacting massive particle. At the energies CERN achieved, WIMPs should have appeared. They didn't. The LUX experiment, the PANDAX experiment, the Xenon 1T experiment, successive generations of increasingly sensitive underground detectors, each one the most precise instrument of its kind ever built, each one designed specifically to catch the WIMP. Each one found nothing. The WIMP parameter space, the range of masses and interaction strengths the particle could occupy, has been almost entirely eliminated. The particle we spent 40 years and billions of dollars searching for does not appear to exist where we expected it to exist. The favored candidate is essentially ruled out. The response from the dark matter community has been to propose new candidates: axions, sterile neutrinos, primordial black holes. The goalposts move. The search continues. The theory remains unfalsified because a theory built around an invisible, non-interacting substance is extraordinarily difficult to falsify. Every null result can be accommodated by adjusting the assumed properties of the particle. That is a feature of the dark matter framework that should make anyone trained in the philosophy of science deeply uncomfortable. But here is the part that genuinely complicates the picture, and where honest scientific humility is required. MOND has problems too. Real ones. It struggles with galaxy clusters. The gravitational dynamics of clusters of galaxies cannot be explained by modified gravity alone without some additional mass. It lacks a complete relativistic extension, though a theory called TVES and more recently covariant emergent gravity are working toward one. It has not achieved the cosmological success of dark matter in explaining the microwave background. Neither framework is complete. Neither framework is proven. We are in genuinely contested territory. What is not contested is this: we have been presenting one side of that contest as settled science. Children learn that the universe is 27% dark matter, the way they learn that water is H2O. As established, confirmed, done. The uncomfortable decades-long string of failed detections, the anomalous galaxy correlations, the JWST structural challenges, the serious and published scientific alternatives, none of that makes it into the documentary. None of it makes it into the explainer video. The story we tell about dark matter is the story of a solved mystery. The actual story is a mystery that has never been solved, propped up by 40 years of failed experiments and retrofitted assumptions, standing across the ring from a modified gravity theory that keeps quietly making correct predictions while the establishment looks the other way. Vera Rubin found that galaxies weren't behaving as expected. We decided invisible matter was the answer. We built the largest detectors in human history to confirm it. They found nothing, and the textbooks didn't change. That's not how settled science looks. That's how an assumption looks when it's worn the costume of a conclusion for so long that nobody remembers the difference. The 27% is real. Something is causing the anomaly. Whether that something is a particle or an incomplete theory of gravity, or something stranger than either, that question is open. Genuinely, fundamentally open. We just forgot to tell you. And that's it from this video. See you in the next one.